Well, folks, it's time to kick it old school. So you can feel cool. Give it to me, baby. Baby. Yeah.
Think classic old school cheater amp, and the Orion 225 HCCA has to be one of the top on the list, if not the most popular ever. 1988, Orion offered gold amplifiers, they offered high current amplifiers, all kind of goodies, but we're going to talk about the first generation of the 225 HCCA, which is shown here in the ad, and here is a 1987 car stereo buyer's guide from Stereo Review magazine. We can see here the Orion amplifiers, and including the 425 HCCA and the 225 HCCA. 225 retail for $469 US. There have been 6 generations of the Orion 225 HCCA from about 1986 up until around 2002. So we're going to talk about the first generation of the Orion 225 HCCA today, called the Moon and Stars. If you purchased one of these back in the day, it came with all kind of goodies, including all the wiring, fuses, the speaker harness, everything that you needed to wire one of these up. Well, why is it called Moon and Stars? You can see here the logo has a moon and a star, and this was only available in the first generation, as well as you can see the graphics. Orion 225 HCCA, 50 watts RMS, handcrafted in the USA. Let's take a closer look at the connections on this amp and what's going on. First off, you see a power LED. There are 2 individual gain controls for left and right channels, RCA inputs for left and right channels. Then there is the DIN input connection. This DIN cable connection provided a way to easily hook up other Orion components because it had phantom power, which would power external devices such as bridging modules, crossovers, etc. As far as the other end, we have the Molex plug connection for the speakers and the power and ground. These are approximately 10 gauge for power and ground. For the speaker connection, we have this Molex style plug with 9 pins. Only 5 of the 9 pins are utilized for left and right, positive and negative, as well as the turn-on connection. And you can see here it's a little bit of a mess. This amp is manufactured to meet military quality standards. So what are you saying, it's good enough for government work?
You big dummy!
As was standard back in the 80s and 90s, the power was measured at 12 volts for this particular amplifier. And according to the spec sheet, 25 watts RMS, 0.005% THD, and a wide frequency range, all kind of goodies. Now, the interesting thing is, if we read the manual, it says 25 by 2 at 4 ohms, 100 by 1 at 4 ohms, 200 by 1 at 2 ohms, but it does not say the 1 ohm rating. However, the 425 HCCA does say that it does 400 watts at 1 ohm when bridged, so we would assume the 225 will be half of that. As far as dimensions, 11 inches by 8.5 inches by 2.25 inches. Now we're going to fire up the good old SMD Demore Engineering Amplifier Dyno and test the RMS power output of this original 225 that has not been touched. Make sure you check the video description for links to Wilson Audio merch. Smash me a thumbs up and subscribe if you like this kind of content. Let's test this stock amp first. Pulled it straight off the wall. Here's that pinky Orion 225 HCCA. It's actually in really good exterior condition, other than the anodization has turned from red to pink. In this first gen model, you had to use one of these BDG modules, or an audio control 2XS would also do the channel inversion that it needed. You can see this one has a DIN plug that's going into the amp, so we're not having to use RCAs there at all. The RCAs are coming in from here, going into this module, which is old as dirt too, sometime in the late 80s, going into this amp, made somewhere between 86 and about 1990. Again, the bridging module was only utilized on the first generation of these amplifiers. You can see here, once we use the module, we use the orange for positive and yellow for negative when we bridge the amp. All these tests were going to be in mono, and we're testing at 1 kilohertz. 8 ohms is first. It's rated 50 watts. That will be 25 by 2 at 4 ohms. Let's see what we get here. Right around 14 volts. We get 58 watts at 8 ohms, certified to 1% THD, 59. So 9 watts over the rated power. It's very nice. Uncertified up to clipping, 1 kilohertz. 62 watts. A lot of people are probably laughing about how low this power output is. But again, these are old school amps, and this is a cheater amp. You'll see why here in a little bit. Dynamic burst, 1 kilohertz, 62 watts. It's rated 50, so did more than its rated power. How about the efficiency? Wow, 40%. Yeah, that's not very good. 4 ohms mono. The amp is rated 100 watts at 12 volts. Let's find out what we get. Certified test is first. 106. Oh, and it jumped to 111 there at the end at 14.13 volts. So again, it's meted its rated specifications. Although our voltage is a little high, this is a regulated amplifier, so the voltage won't matter all that much. Uncertified 118 at 14.15. Let's try that dynamic test. Sends a 1 kilohertz pulse tone into the amp. Simulates the IHF 202 test for dynamic power. Again, being a regulated amp, it's not going to have big dynamic power, but 119 watts at 14.18. Efficiency, 44.6%. That's Class AB, kind of low rating there for Class AB. 2 ohms, 200 watts is what it's rated. Let's see what we get here. Certified test first. And we got 195. You notice it jumped from 147 to 195. But it did measure that on the dyno, so we'll go with it. 195. Uncertified, we do get over 200 watts. So we're still meeting its ratings. 203 at 14.09 volts. And then dynamic. Very close to identical to the uncertified test. 209 at 14.13. How about efficiency? We're dropping into the dirt. 33.6%. Yikes. 1 ohm mono. We think the amp is rated 400 watts, but it does not say it anywhere in any of the manuals for this first gen. Certified test first. Did not get anywhere near that. We got 221 watts at 14.06 volts. A lot of people are complaining that this amp is older and it's not been upgraded. You know, the capacitors are still original. That is a fact. However, I don't think that changing capacitors is going to make this amp do its rated power. 267 at 1 ohm, 14.06. Dynamic. Again, well shy of that 400 watts at 1 ohm. We got 269 at 14.09. Up 270, it jumped up a little bit. As far as efficiency, the lowest I think I've ever measured, 30% efficient. Wow. Now we're going to talk to Shawn King about his modding of a 225 HCCA first gen. All right, guys, today we have Shawn King here, and we're going to talk about this Orion 225 HCCA that he modified. And the biggest question I have right off the bat, Shawn, is why did you do this modification?
A few reasons. One is just for fun. In addition to that, I was kind of hoping to do the old school SPL challenge in the spirit of the quote unquote cheater amps back in the day. I was like, well, how about I, make this little cheater amp of my own? Try to make this amplifier produce, twice the power that it was rated for. In addition to that, now, if you're going to make a video out of this, it might be nice to show the public just how much time and effort really goes into trying to make it an existing amplifier actually produce more power. I think it's a lot more involved than many people think it is. This is the very first generation of the HCCA 225. First and foremost, the thing that you need to do is if you're going to try to get more power from an amplifier, for the lack of a better term, beef up the power supply, okay? You're going to have to raise the voltage that the power supply can produce in order for the output stage to create more power. First and foremost, it was, my thought process was, okay, let's completely gut the stock power supply, and then we'll start from scratch. Try to fit a transformer in there physically as big as possible with a wind count that will give me a higher voltage in the output stage. Okay, higher rail voltage. So that's basically the heart of a switch mode power supply. Okay, that has an SG3525 pulse width modulation chip that sets up the frequency at which your power supply transistors are going to switch at. That essentially sends a signal to turn the transistors on and off at a specific frequency that you choose. I basically did that from scratch and chose my own switching frequency and chose my own components and everything. Also, you can see in this picture, it's a little bit hard to see, but going from the old self-oscillating power supply to the more modern pulse width modulated power supply that uses the FETs, of course, the traces on the board were not going to work, right? So I actually had to cut a lot of the traces. I had to solder, for instance, I had to solder in gate resistors, run the leads to the power supply transistors from that board. That's kind of why you see some of the wiring the way that it is, because there's nothing on the board that I could actually use. Upgraded everything as much as I possibly could. You really can't have too much capacitance. It's really what you can physically make fit inside of the chassis. Of course, the input filtering caps those were upgraded, of course. And then all of the rail capacitance was upgraded. For starters, we had to upgrade the voltage rating on them anyway, since we're stepping up the voltage much higher than the factory. The capacitors obviously have to handle that extra voltage. So we had to do a higher rating there. The smaller capacitors, those are also still rail capacitance. And I basically just added those just to see if it would help at all. There's some theory out there where they will supplement your large bulk capacitors. So if you do multiple smaller capacitors that are in parallel with the rail capacitors, there's some theory there that they can supply the current a little bit faster than the big bulk capacitors. And it was just something I was trying to see if I could just squeak a few more watts out of the amplifier. We're really pushing the limits as to what can physically fit inside of this heatsink and how much current is being pulled through the entire amplifier. So, I was just trying every little trick that I could think of to gain every last watt that I wanted. So my goal was to try to pull about 800 watts out of this amplifier. So I guess I didn't point out either too, like in the output stage was heavily modified as well. So you can see the transistors in there are TO247 devices, which are significantly larger than the TO220 devices that were originally in there. So those devices were upgraded to handle the extra current, and the drivers that drive those transistors were actually upgraded as well. There's very little in there that's actually the stock amplifier.
Well, that's cool. And again, we'll show comparisons with the gut shots of both amps, because I have an original 225 HCCA first gen that's completely untouched, unmolested. I will show that one. We'll try the power output on that amp, and then we'll also show the power output on this amp and see if Shawn's work really came to fruition or if it was just a waste of time. I guess we'll find out. Well, thanks, Shawn, for joining me today, talking about your modified Orion 225 HCCA. I think we're all excited to find out what it will do. And thanks again for your time. It was good hanging out with you.
Sure. Thank you.
Okay, now we got the explanation of this modified 225 HCCA. Let's test it out. All these tests, again, are in mono, and they're also at 1 kilohertz. 8 ohms first, rated 50 watts at 12 volts. Let's see what we get here. Certified to 1% THD. And already, whoa, check it out. 253 watts at 14.18. Significantly more than the other one that we tested that was unmodified. Let's try it uncertified up to the clipping point. $253 at 14.18. Very nice. This amp does more at 8 ohms bridge than the factory one does at 1 ohm. Dynamic power, 273 watts at 14.22. Now, what about the efficiency of modifying the power supply? Look at this, 75.3%. That is close to Class D efficiency. Very, very good here. 4 ohms mono. The amp is rated 100 watts at 12 volts. Let's try it out around 14 volts. Certified test to 1% THD. Wow. 421 watts. The factory one got just over 100. This one does 4 times the power of the factory 225 HCCA. I'm blown away. Uncertified up to clipping. 421, 14.14. How about that dynamic test? The 1 kilohertz pulse tone keeps going up. 486, 14.18. Let's check that efficiency. 66%. That's still good for a Class AB amp. Now let's wire it down to 2 ohms mono. It's rated 200 watts at 12 volts. Certified test first, up to 1% total harmonic distortion. 596, almost 600 watts at 14.06 volts. Insane. Shawn's mods are just crazy on this amp. Uncertified up to the clipping point. Over 600 watts. Look at this, 622 at 14.05. This amp is pushing the 2100 HCCA power, honestly, in a 225 HCCA heatsink. Dynamically, over 800 watts. Now, you remember Shawn mentioned before he wanted to be able to get 800 watts out of this amp. Well, he's already gotten it. 14.13. Efficiency, right around 50%. Again, Class AB, that is expected. Now, what about 1 ohm? Shawn told me this amp is really designed for 2 ohms, but he said I could try the 1 ohm test. So let's try the certified test to 1% THD. 716. You notice it jumped from 5 something to 716. So it's not extremely clean on the certified run, but the uncertified run, check this out, up to clipping 774, 13.93. So right at that 800 watts he was trying to get. But dynamically, look at this. There is no turbo button on this amp, but we got over 1100 watts on a 50 watt amp. Incredible. 43% efficient at the 1 ohm rating. Now let's look at the results just as a recap to see how the stock amp versus the modded amp performed. At 8 ohms, we got over 4 times the power for the modded amplifier than we got from the stock amp. That's just crazy. At 4 ohms, again, over around 4 times the power from the certified test to the modded. And yeah, 116 versus 421, you're definitely going to hear that. And 2 ohms drops a little bit, but still 195 versus almost 600 watts, so over 3 times the rated power. At 1 ohm, over 3 times, 3.5 times or so the power from the stock amp to the modded amp. So wow, Shawn's mods really paid off here. Fantastic job. This was a fun little test. Sorry the video was so long, but I thought we needed to get into that. If you guys want to see these power and subwoofers, or if you want to see any additional tests with these amps, just let me know. Special thanks to my Patreon subscribers. If you are a Patreon subscriber, you'll have access to the unedited version of my interview with Shawn, which went on for about 17 minutes. So make sure you check that out, patreon.com/oldschoolstereo. Big D, I'm out of here. So there's a lot of work going on here, and I'm going to have to ask the question. I already know the answer, but I'll ask it anyway. Would you ever do this again, Shawn?
Unlikely.
I figured so.
Unlikely.
It's like,
yeah.
so don't call him up and ask him, to do one of these unless you just have way too much money and way too much time.
Well, I mean, let's face it. Especially being a Class AB amplifier, the heat sink can only dissipate so much heat, right? And this guy will certainly turn into a toaster oven if you wanted to. So yeah, I mean, if you put a fan on it, maybe it would last a while playing music and stuff. But this was my initial intention was to just use it as a burp amplifier, right? So it wouldn't really matter. the how long it would have to last.